Welcome back to class. I'm glad to be talking commissioning today, and let's dive right in. Well, I was trying to think of the best way to go about explaining commissioning if you'd never even, um, I don't know, what do you know that might require some level of commissioning? So the idea behind commissioning, maybe start with that, is that trying to make sure that the mechanical, electrical, plumbing, fire suppression, whatever other dynamic systems are in the building exist, are functioning as they're intended to, as the designer intended, and functioning efficiently. And so there can be a whole lot to that, or there could be very little to it, depending on what the building is and what uh, how many points there are, how many systems there are. And I like a friend of mine described it this way, that it's a lot like layers to an onion, and so everything is sort of connected. In that, when you think of maybe they're trying. Hopefully, you're back following where we're looking at right now. We're looking at a building, and remember, this building has a bunch of VAVs in it. And could you go to this VAV and make sure that it is working? Is that the first thing to go look at to make sure that it's working? No, it's connected to a whole bunch of stuff. So um, when my friend talked about it being like a layers of an onion, you really got to think through all those different layers to the pieces of equipment and what's needed to be worked on first. I use that word worked on because I'm not trying to use any specific word yet, but so that you can get to a point where all of it is working. And uh, my friend was kind of like saying, you complete one layer of it and you get another layer and another layer and another layer, and eventually the whole thing works as an onion. Anyway, I don't know if that helps or not, but I don't think commissioning's anything that the construction industry really. Um, I don't. I think in my career it's definitely grown. I don't know that it started in my career, but I don't know that it's very old either, because it seems like some of the older generations had never heard of it in commissioning, and like, why are we doing this? And so we never used to do this kind of statements from some of my mentors. They have a good point. Maybe I'll share like some of that. Um, maybe now, like the point of commissioning is to do a bunch of uh, tests and inspections to ensure that the equipment is running as it is. And so, one from a big picture, a client might hire us as the general contractor, and then they'll hire a commissioning agent as well. And from some of my mentors' thoughts is, why would they even bother to hire somebody else to make sure that it's the mechanical equipment's working? Why doesn't the mechanical contractor make sure that it's working? So he works for the general contractor. Why would he install something that doesn't work or isn't functioning correctly? I mean, so there's an argument to be said that kind of goes along those lines, that somebody hiring a general contractor should have a reasonable assumption that that general contractor will make sure that what they've been contracted to do works properly and is functioning correctly. And so, why would you hire a third party to come in and do that and make sure that it is all working right? Um, well, I think there's a lot of uh, competing interests towards the end of a project, and the amount of time given to be able to on any given project varies, but almost always a client sees that their project's getting close to the end and they want that project to go start doing whatever their intended use of that project was, whether it's a retail space, or maybe it's an office space, or something to do with I don't know, a hotel, or education or hospital or whatever, right? And so they need to get that project functioning and doing what it's supposed to do, and want to bring client their their clients in to do whatever they're going to do with them. So say it's like this building right here, they want to be able to put people in the office, and they don't want to spend a couple more weeks commissioning out the building. And so on a typical contract, just average contract, not without commissioning, it'd be up to the general contractor to ensure this is done, and typically ends with something called TAB, and I'll explain it more, but test and balance. And once you're done with test and balance, then you're turn the building over to the folks, and that's kind of how far you get. You're also supposed to do equipment startup based off manufacturers and stuff, but that doesn't guarantee that any equipment is really running most efficiently, or that there's not a lot of time to try and figure out whether each individual parameter is actually doing what it's supposed to do. And so on government buildings, for sure, the ones I've been a part of, they mandate commissioning. And anything that has a lot of complexity, I highly recommend going through some sort of commissioning process. And the commissioning process can range quite a bit. I remember being involved just briefly. I should say super briefly, with a lab. Meaning, like, all I did was walk through and talk to our subcontractor doing the controls. That's all I did. Walk through the building and look at it. And as a corporate guy at the time, they did a good job on the project. Didn't need to be involved at all. But all I was doing was chatting with our controls contractor, who invited me out to go look at some stuff. And the point being, I think they were going to spend a good 2-3 months going through all the systems in the lab and making sure it's all functioning. I mean, it was a lot of commissioning to be done on that. So I don't know if it helps you to think through other things that they get manufactured. Say you get like something that's complicated, like I don't know, a car or truck. You'd want them to make sure that it was functioning right before it was sent off to the dealership or whoever is going to buy it. So hopefully there's some tests going on through different stages of the assembly of that car, manufacture of that car. Make sure all the components are working. Some sort of final test before they turn it over to the client or to the buyer. Think through like large pieces of farming equipment, like a combine or something like that. There's a lot of systems to test out. Mining equipment, all kinds of stuff like that goes through a bunch of checkout. Well, for some reason, when you buy a building, it's not very common to go and say, hey, no, I want my entire building checked out in the mechanical, electrical, and plumbing system. It might be way more expensive than like a combine or a truck. And some buildings I've seen have way more testing. Far less testing specified by the client than, say, an equally priced piece of manufacturing equipment, or, like I said, like a combine or something like that. Cost could be very similar, but the testing at the end is nowhere comparable. So I'm a big fan of commissioning. I hope you're hearing that. I think that it's worthwhile. And the time spent in a corporate role where I had a little bit of support of our warranty department, I think I've said this before, but mechanical, electrical, plumbing issues far trumped any kind of, by quantity anyways, warranty tickets than any other part of the building. And I think the next closest was like doors and windows or something like that, if you broke it into divisions. But it was like a factor of like 10 when you put mechanical, electrical, plumbing next to the next closest one. There's like this huge spike, and then it drops off way far down. And so the number of warranty issues by division, mechanical, electrical, plumbing, are way up there. So commissioning is a good thing from my point of view. That I should definitely do that. So, trying to describe a little bit of what commissioning might be, let's look at Wikipedia. And so I wouldn't hesitate to read through this article right here, but I'm going to give you some language. You see the CX, that's the idea of commissioning right there. OPR, owner project requirements, design intent, that's all language associated with commissioning. O&M is not a commissioning lingo. It's pretty common, operation and maintenance. But OPR, owner project requirements, design intent, definitely you're going to hear those kinds of words. And let's cruise down. I think the best description they had. This is a little bit of history and practice right there. Okay, so the CXA, the commissioning authority or commissioning agent, and last time we were talking about LEED. LEED is definitely a fan of commissioning because it's energy leadership in energy and environmental design, right? And so you can optimize your equipment, how it's running, by going through the commissioning process. So yeah, they're a big fan. And so commissioning agent gets involved, and the overall process would go something like this. If we were doing a LEED project, the commissioning agent would be involved, and he'd review the owner project requirements and develop a commissioning plan based off of the owner project requirements. And usually the commissioning plan has something to do with reviewing some of the submittals for the mechanical, electrical, plumbing. It has to do with some during construction inspections, on top of just like your normal inspections that you get from city or jurisdiction or specified testing. This commissioning agent will come out and look at some things during construction, develop some checklists for both install and startup, and then something for functional performance testing. And so this commissioning plan gets developed by the commissioning authority or commissioning agent, and kind of taking you through. It's like from pre-construction, looking at the owner project requirements to the design to the submittals, then during construction, some inspections is dealing with some inspection checklists, creating some of those, and then getting to this functional performance piece, where and I like how they said this, with the assistance of the trade contractors, vendors, and manufacturers. So this commissioning agent works with the various parties involved to take the equipment through test procedures to make sure that it is functioning correctly. And it could involve a BM, building management system, or building automation system. We've talked about that with like control systems. And a lot of times the more building automation or building management that's involved, the more likely you're going to need to be able to do some level of more advanced commissioning. And so you've heard this term, SOO. What is that? That's the sequence of operation. So some of the plan that gets put together, and then the functional performance tests, they should be based off the sequence of operation. And then there's something called point-to-point, which I'll go over in more detail. And I'm just trying to do a high-level overview. So once they're, I think I skipped a step though. I think in here reading through it. So if we went from like the early design to submittals, so we got the owner project requirements and the design being reviewed. We get the submittals. You're getting into construction, and the commissioning agents doing some checklists. I think one of the things that I didn't mention was startup checklist from the manufacturer, even though it sort of said that here, was that they work with the manufacturer a little bit. So you get different pieces of equipment started up and run through its paces as far as the manufacturer checklist goes. And that's an important part. But that doesn't necessarily mean that the entire system is working as a system and is running efficiently as a system. But the pieces of equipment can get started per the manufacturer's startup equipment startup checklist, and then you're going into more of a functional performance test, functional performance procedures. So let me kind of define that stage a little bit, and then we'll go back and maybe talk a little bit more about test and balance and point-to-point and FTPs and functional performance testing in more detail. But let me just focus on, we're at the point of trying to get equipment to run, and I'm trying to define where this startup of equipment transitions into functional performance testing. Okay, so we have this, and in order to do that, I'm going to walk backwards a little bit. So what would the commissioning agent see during like the design phase? They would be expected to review some, like all or some of the mechanical drawings, the electrical drawings. They're doing the same thing that a good general contractor should be doing, and they should be looking for coordination issues, potential issues on energy savings. They should be making sure, putting another set of eyes on constructability issues during the design phase, and they should be then putting together a series of checklists, right? And so the checklists, they would be then again reviewing some submittals, and you're starting to build this, right? So we're now building what you see on this drawing. Well, the manufacturer of this air handler right here has a startup checklist. Also has a startup checklist for air handler 2 and 3. And so for all this equipment, how about this condensing unit 1 and 2? For sure that it has a manufacturer says how you get it started. The diesel generator, for sure. There's a, whoever this diesel generator is, I don't know who provided it. I don't remember. It definitely has something to say. This is how you get the diesel generator working. But the point is, how do you get all this stuff, all this equipment to work in harmony with one another? So the diesel generator is going to be involved only when the power goes out. So how is it tied to the rest of the building's power service, and how does it work in harmony with that service when the power goes out? How does that start up? What does this diesel generator actually provide power to? And so once you get past like how the generator gets started and is working on its own, the next phase of that could be considered point to point, or maybe that's too micro detail right now. But the next phase of it is to ensure that it is working as a system. And it might be easier to think of this air handler for a second. We spent a lot of time on this set of this drawing right here, right? So we have this air handler, and the air handler supplying air through this duct right here, but then there's a series of VAVs, right? So there's a VAV right here, and a VAV over here, and VAV over there. There's all these VAVs everywhere, so it's an air handler VAV system, right? And so the VAV manufacturer is different than the air handler manufacturer. They're two different pieces of equipment. So to start this and get this running, and then to try and make sure that this is working, and then the next phase is to try and make sure these work together, that this is working as one system. So when you start thinking through like why this is so important, as far as when you're doing commissioning from a general contractor standpoint, a lot of it I've seen, I shouldn't say this, I should be critical, but most folks from the general contractor standpoint did not come into general contracting from the mechanical and electrical world. There are a few, but most of them come from like the structural side, or right into being a general contractor, or civil side I've seen a lot, architectural side. Very few come from the mechanical, electrical, plumbing. So it's not a language that they're like coming from. And so I've seen managers not manage the commissioning phase. And so what has to be what am I saying when I'm saying manage the commissioning phase? Well, let me go back to that onion thing for a second, that onion example. And there are systems, and then there are subsystems and subsystems. And so when I'm going to say, and there could be, think of the whole building as a system, but I'm just going to use the term system and subsystem, okay? So let's call the VAV a subsystem, and the air handler is subsystem, and all the any mechanical piping that's in here going to this as a subsystem. And what makes it turn into a complete system? Well, when all that is working together, when all of that is functioning correctly. And so if this is a reheat coil, and I think that it was, I think we looked at that, and I'm pretty sure it was electrical. Should we look at it real quick just to make sure? I think we should. Okay, I thought they were. Unit heater, VAV, number 3. Yeah, it's a electrical heating coil on the VAVs. So one, I should say VAV with a terminal, I think is the more correct way to say this is a heating terminal on the VAV, because the VAV just adjusts the damper, right? And then the terminal can heat up the air again, because the air is coming out of this at, I forget the temperature range, but 66 and 55. So it's coming out at either 65 or 55 based off the return air temperature. Then it hits this VAV box, and one option is for this VAV box to open and close the damper a little bit to either let more air in based off does it need more cooling or not. And then if it needs more air based off of the air exchanger, but the air is too cold, it turns on the terminal here, and the terminal would then heat up the air so that it's not cooling up the space too much while it's trying to provide the air exchange, right? Okay. We talked a lot about this. I'm just trying to go backwards a little bit to get you caught back up. So if we go back to this right here, and we're saying system subsystem, one of the things, you just have to think of the whole thing that the general contractor is trying to do. One is provide a contract with a subcontractor that is capable of doing this work, has capacity for it, knows and is proficient in it, and then also is able to do the level of commissioning that we need. If we're going to hire a commissioning agent, or the owner is going to hire a commissioning agent, the contractor needs to have people that can interface with them. We need a controls contractor that can interface with that kind of person. Most of them can. Can't think of too many where I've thought, dude, you really need to spend some time thinking how to communicate with a commissioning agent, but I'm sure they're out there. Most of them are really good. So the question is, what are the subsystems and subsystems? Now, let's say, for instance, for a second, that the flow of construction happened from left to right, just for instance, okay, of this little building here. And they got to a point where maybe this whole half of the building was all finished, ceilings are in and everything, and they want to say, okay, well, can we start the commissioning now? Well, what's over here on this side of the building? Well, this is where we have the air handler and the cooling, condensing units, excuse me. And so could you theoretically do commissioning over here? Not much. You could maybe get some power over here if the electrician could get some things going. You can maybe bump these little motors, the actuators, see if they're working, but you can't really do anything until you have this whole system. And that's kind of the point, is the air handler is really a critical component, a critical part of the system, and it even has subsystems, right? So the air handler isn't a standalone system either, or a standalone subsystem. It has subsystems associated with it. So let's go look at it. So it has all kinds of stuff inside that needs to be working. And we've got the condensing unit, we've got the air handler, we've got relief air, outside air, we've got different cooling coil, electric coil. What needs to be done in order for this thing to be working? Well, quite a bit. What about the smoke detection? Yeah, for sure. There's a lot associated with this air handler that it's not just turn the switch on and have it go. There's a bunch of subsystems involved in the air handler in order for it to be functioning. So it can be a very, what I'm trying to get at is people ignore it, basically. because it's complicated, people will, from the general contractor side, for good or bad, will ignore how much work there actually is to get something going, and they'll ask the wrong questions. But let me explain a good question, and the good question is, what are the subsystems associated with this? So if you say, can you give me a status of the subsystems for the air handler? Can you give me a status of the air handler? Don't say, when are you going to bump the motors on the air handler? Or when are you going to start the air handler? That doesn't tell us anything. We need to know the systems and subsystems associated with it. If you just say, when are you going to start the motor or start the air handler, they're saying, okay, well, they're going to interpret that as the startup checklist. And the startup checklist is going to make sure that going back to the manufacturer is going to say, okay, do something to make sure that this fan is running in the right direction. Do something to make sure this fan is running in the right direction. Operate all the motorized dampers, make sure that they're functioning correctly. So you're going to have all these little checklists associated with this, and that's the startup. But that doesn't mean that the air handler is functioning. So you need to know the systems and subsystems. So if you say, let's for instance talk about air handler 1, air handler unit 1. Can you just give me, mechanical contractor, a breakdown of what subsystems you need online before you can go do a full checkout of the air handler? So what subsystems would they need online? Well, he needs power, he needs VFDs, he needs the power to the condensing unit, he needs power to this. And he's going to start listing all this power stuff. And then you might say, okay, what plumbing do you need on this? And in this one, it's just the cooling coil. And so it's not necessarily the plumbing, it's mechanical piping. So you might want to say that. What mechanical piping do you need flush filled tested? Is the status of the mechanical system? How's the mechanical piping on the air handler looking right now as far as the status? Are you flush filled tested, vacuumed out? Probably just vacuumed on the refrigerant. Sorry. So but I see like the language go to more of, when are you going to start the air handler? Yeah, that doesn't help. And it's just one part of the entire, one startup of this does not mean that the entire thing is working. It's just one step in the commissioning process. So, what would you really need for the air handler to work is the question. And are people coordinating towards that direction? And I was trying to make the point earlier, so let me tie it together, okay? Construction might be going this way from left to right, meaning we're rough framing over here. They're doing rough electrical over here first. They're doing rough plumbing over here first, and then it's all going this way, right? And so this part of the building is done before this part of the building. Let's just say it is, because that's what we decided to do for some reason. It seems backwards to me. It should have gone the other way. But let's just say that's what the constraint was. Because of how far away, say you got these diffusers in, the diffusers, the registers are all in. It can look like a finished space and the work can be progressing really well. But there's a big distance between this and that. And so if the work is going from left to right, just because you see a finished product in one space doesn't mean that you can complete the entire system, or it doesn't mean that the system is complete, because it's connected. It's all connected over here to this air handler. I'm hoping that you're seeing that the sequence of construction for the other trades is not necessarily the sequence of startup, test, and functional performance testing. They're not the same. So let's just take lighting, for instance, okay? Let's do something simple. Let's say we had all these offices completely painted out. The grid ceiling was in. We're working our way this way. We're doing awesome. Great project. Everything's good. And then we hit this communication room and the electrical room right here. And we're finally painting this room right here. What does that mean? If we're barely getting to the point of painting this, then we probably haven't set any of the panels on the wall. We haven't been able to get any of the wiring terminated. And so just the physical distance between here and here would mean that the lighting and the outlets are probably not going to be done by the time the rough construction hits this phase right here, this room. So we need to actually think through that a little bit during construction and put a couple of these rooms in sequence with the early rooms so that they're done about the same time, so that you can actually do something when these are done. And it can get more and more complicated when you're going into buildings that are multi-storied, or getting into something with like a central utility plant, like at the college it has a central utility plant, right? So it can be very complicated. But what I'm trying, again, if I'm going back to the exact point, the point is the sequence of construction doesn't match usually the sequence of startup test, and you can't just assume that because something is done over here that it should be tested out because it's connected to some mechanical system in some other part of the building. Where that wouldn't necessarily be the case, we're looking at this. So if we started over here on this side and went that way, well, if you remember what was in these rooms, they were all kind of like standalone pieces of equipment, and all we needed was these air handler 2 and 3, and we could get this stuff going. So if we worked from this way going that way, it's much more likely that when this was completed, we could actually do something with it, because there was floor condensing units, and I think the other condensing units were out here somewhere. I forget where. But you worked this way, and I think I could make an argument that we could probably get something going in here for startup test, even though the rest of the building wasn't done because it's not connected. They're not connected. This ducting over here is all going to air handler 1, where air handler 2 and 3 are feeding this one. So if we did air handler 2 and 3 and had the electrical room going and some other components done, we can make the argument that, yeah, that could be done. But then the exact argument that I'm making is that we start completing stuff going this way, and really you couldn't say that the whole thing is ready to be all tested out until you had this guy going and all these offices done. Hopefully that wasn't too much, but let me give you a list of some things that when you think of like systems and subsystems, have a little bit of a list here. Piping and ducting, power, motors, pumps, fans, the main utilities like gas, water, sewer, data. How about individual components like boilers or heat exchangers, air handlers, rooftop units, individual controllers, the building automation controllers. Now we're getting chillers, cooling towers, refrigerant lines, water conditioning, snow melt. As you start thinking through all those subsystems, or even maybe call them components, that's a lot of stuff that could be involved in trying to get this building to work. And so what I like is actually getting into the project and working with the commissioning agent and working out a startup sequence so that we can have, if the electrician's working on whatever panels they're going to work on, if we can coordinate with the electrician to provide power to certain things at certain times, and that works out for the electrician, then we could maybe go ahead and say, okay, we're going to plan to do maybe reversing the sequence. Maybe we're reversing the sequence, we're going to construct that way. And that means, Mr. Electrician, we're going to try and do air handler 2 and 3 first before we do air handler 1. And we're going to try and get some of this control room stuff up and operational before we go work on air handler 1 and all the ductwork and all the VAVs. So what does that mean? Well, we could get into all this equipment and break down, okay, well, this equipment is, now start thinking through it, okay, motors, pumps, cooling towers, refrigerant lines, to start thinking, oh, we could complete this stuff, get it going, and run through the commissioning process here. While that is all getting finished up ductwork wise, maybe we have to do something to be able to partition this off somehow. I don't know. It was just an idea. But let me give you some more stuff, some more words. So power to equipment, equipment startup, pressure test, flush, fill, and condition, performance verification testing, test and balance. Now I have some other things from like the state, like state boiler inspection, Department of Health. Those are some language. One of the things that I wanted to talk about a little bit is flush, fill, and condition. Okay. We don't have a good example on this building. Don't think there's, let's see. Oh, let's see what equipment we have here. Plumbing, expansion tank. Dang it. All right, let's just use this for instance. And we're going to change this electric heating coil to a hot water coil, okay? And what would we need in order to do that? Say it made that change and automatically got that done. Well, it would be a boiler. And so it would be, instead of an electric heating coil, you'd have like a radiator type heating coil in there. And you have a boiler somewhere. And we did that on in the 4-story building we were looking at a while ago, but I'm not going to bother to bring it up. But one of the things with boilers, and you have piping between the boiler and this, and the piping is dirty, and so they have something called a flush. So when I couldn't, we might be able to argue that they're going to do a pressure test on the piping. Let's just say they do. They're going to pressure test the piping between this coil and the boiler, and that all passes. Then the next phase is to flush that piping. What do you need in order to flush piping? Well, you need to run water through it. And so how do you run water? You need a pump. So in planning some of this stuff, getting power to pumps sometimes is a critical thing. I might need power to the pump before I ever need power to the boiler, so that I can flush or pressure test, then flush, then fill, then condition that piping. So on the scheduling, whenever I've been trying to share some of this info with folks on scheduling this, and you have some sort of mechanical piping like that, and you have a piping that's like I said, like boiler water, put in the schedule, and I'm talking short-term schedule now, not the master schedule. Probably wouldn't go to this level of detail with the master schedule, but put in the schedule that you said flush, test, and fill, or pressure test, flush, fill, and condition, and put that in an activity, and then you can actually follow up on the activity rather than, hey, how are we looking on the pressure on the mechanical piping? Oh, good, we passed our pressure test. Okay, well now you have to realize that there are more steps involved before you can go turn the boiler on, because the piping needs to be there before the boiler can get going. Because how are you going to start a boiler that doesn't have any water in it? How are you going to start a boiler with water in it if you can't move the water somewhere? It's going to immediately turn on, warm up, and then immediately shut off. So there's no load. Now think through that for a second with me here. We have a boiler. Do we need the boiler started before or after this air handler? Well, I'm going to make the argument that the air handler needs to be running and be able to blow air, and then we need to start the boiler up. But we need to flush, test, fill, and condition the piping concurrently with the air handler being worked on, so that when we're ready to start this air handler up and then start the boiler, the point being we need a load on the boiler in order for it to be fully started and work and tuned. So think of like load as well. Like there needs to be, I don't know if the right word I'm using might make sense. A demand. Does that word make more sense? There needs to be a demand for whatever it is trying to accomplish. So if it's the hottest part of the year and we're trying to say this is not an electric heating coil, we're still talking about it being like a boiler water heating coil, and the air handler is trying to cool everything down, there's not much of a demand for boiler water. So it's hard to get that boiler started up and running correctly without much of a demand. So you might have to fake the demand. Might have to put this entire cooling coil going. You might have to figure out a way to create cold air coming back from the return side so that we could then tune that. Or you might just have to wait until there's colder air, and then there's a demand for it. And vice versa with the cooling coil, right? If the air is already cold, how are you going to make a load for this condense the refrigerant cooling coil here? Well, that would be more simple because you could actually heat up the coil right before it with the boiler, and then you could immediately cool it off right here with this one to test it. But the point is you need a load, and I'm hoping that you're seeing that level of what subsystems need to be worked on. And you don't have to be an expert in this. I'm not asking you this level of your class to be an expert. I'm going to try and explain as a concept and give you a couple examples that don't want you to fall into a trap of ignoring it and just thinking, oh, we're completed in a space, we're done, let's turn the space over to the client. No, we're not done. We still have to get this air handler working on all this stuff over here. And in order to get the air handler going, we need the condensing units. We need whatever else is involved. If we had a boiler, like I said, that boiler water or whatever, the electrical pumps. Anyway, all that kind of stuff. Hopefully that made sense. So I think those are important questions that we're asking. Like, can you think through the system and the subsystems? And can we status based off that rather than just generically going by startup of, because the term startup is super common. When are we going to start the air handler? And I think I've shared this story before where the project manager was asking the mechanical contractor on a project that I was involved in. And I was there from a corporate perspective trying to give some support. And the team did a great job on this project. So if the team ever hears this lecture, dude, I'm not trying to be critical at all. But this was the wrong question, and I think the project manager would maybe agree to it. He was asking, when are we going to start up the chiller? Well, the chiller is one component, because what he really wanted to do was provide cold air from the air handler to the rest of the building. He was trying to cool the building because it was going to get hot. And he didn't want to be putting in a bunch of cabinetry and other finishes like carpet in a really hot space that actually needs to acclimate a bit, and you need to be somewhat conditioned. So he was asking, what he was saying was, when are you going to start the chiller? What he was actually wanting was, when are we going to be able to provide air, cold air, from the air handler to all this space? And very different questions, because the chiller is a component in a larger system, and he was asking about a very specific component, the chiller. And so the mechanical contractor said, hey, we got the startup guy coming next week. And so there, oh, we're saying, all right, great, we're going to provide some cool. That's in the project manager's head. He's like, oh, great, finally, we can get that chiller going. Well, there was no piping completed between the chiller and the cooling tower, or the cooling and the cooling heat exchanger over to the air handler. None of that was completely flushed, tested, and filled or conditioned. The air handler wasn't running. So what's the point of starting one component? Well, it's a great step, but it's the wrong question. It had there been a whole series of questions like that. Can you give me the status of the chiller? Can you give me the status of the cooling tower? Can you give me the status of the piping between the air handler and that? Can you give me the status of the air handler? Can you give me the status of the boiler and the boiler water? Well, that would have meant that the project manager had a really good comprehension of what was involved in the entire system to make it working. And I think that's my point that I'm trying to get to is if you can understand the systems and subsystems, you can have a really intelligent conversation and not get, like, I think the idiom is wool pulled over your eyes. I might be using that wrong. I'm not a good idiom guy. All right, so let's get into some more details. I already talked way too long on this topic. Sorry. Let's see how long I've been talking. 45 minutes. Oh, geez. All right. I hope that was valuable to you. If you're getting into the commercial world, I hope it was. So let's see what I have over here. Okay, let's go back to test and balance. Do you see the 265, 265, 120? What are all those in there? That's how much cubic feet per minute air needs to be coming out of the diffusers. Okay, so this one needs 120. Looks like that one's going to get 75 cubic feet per minute. And how do they actually make sure that you get 265 cubic feet of air per minute? One, they put a hood underneath this, and when it's finished, so they need a finished space with the ceiling in and the doors on usually. And so it looks like a finished space, and everything's kind of running. And then, do you see this little thing right here? That's a damper, manual damper. And so they'll be able to manually open and close this to be able to allow more air or less air into this duct so that they can read that they're getting 265 cubic feet per minute. And what do they put over the top of it? A hood that would be somebody like that, or somebody like this, standing in the space over the diffuser and reading how much air is coming out of the diffuser, and then opening up the ceiling, turning this a little bit, and then rereading it and say, okay, that's correct. We got the right amount of air here. Come over to this one. Let's read it. We need to adjust a little bit. So come over to the damper and adjust. That's the idea. Generally, the idea behind test and balance. There's more to do. There's actually quite a bit for them to do, but I'm not going to spend a ton of time on that. I am going to say that as they're trying to read these values, and people, again, we're competing for the end of the project usually, and so it's a scheduled activity that needs to be scheduled. It's going to have to be obviously part of somebody's contract, and so there's all kinds of stuff there. There's they're going to be a part of the startup reports, or part of the O&M manual to have the test and a balance report. And so don't ignore test and balance, and then know that when they say, hey man, I need actually to have the door closed, why don't we put the doors on? Or why aren't we I need all the ceiling done to be able to read this. Why would they need that? Well, it's different pressures in the room when the door is open versus the door is closed. So it's going to be kind of like misleading to say how much air is coming out of this if, like, all the doors in the entire building are off and air is able to flow any which direction. So it's not really going to supply a good example of how much air is coming in here and out that versus in here and out into this space, or out into that space, or out into this space, right? So with all these doors opened up, it wouldn't really be coming out here and then into this space, right? A6, I'm assuming that's an air transfer duct. Yeah. So test and balance, something that needs to be scheduled, kind of. And I go back to that picture. That's what they're usually running, something like that. There's other ways to do it. Yeah, I don't know all the other stuff. I'm not a test and balance guy. I just know that we need to schedule them. All right. And I know how to read the manual now. We'll read the report, see how it's going. Okay, I wanted to talk test and balance, talked about commissioning a little bit, and let's go to another part of test and balance, and it's the point to point. So what am I saying when I'm saying point to point? Do you guys remember these point lists? So what they're doing, and I have a white paper that I copied off the internet that I like. I should probably give the dude credit, but somebody overseas wrote it. And so he's saying, whoever wrote this is saying that point to point is a crucial part of the commissioning process. Well, what would you need in order to get to the point of doing point to point? Well, generally you'd have to have the air handler started and running, kind of. And then you could start to see if the return air temperature sensor is actually reading. And is it reading correctly? And maybe there's a couple return air temperatures. What if the let's see, return mixed air temperature. Okay. Number 10 and number 2 are both reading temperatures, and they're just little tiny wires. And so kind of the point of point to point is to make sure that, one, somebody hasn't messed up, to see if they're the wrong the wrong sensor is being read, or is the sensor reading correctly? Is the, I don't know if you remember this, but like some of it is what's the right word? It's binary versus analog, I think is the term, where it's either on or off, or it's a grade within the milliamps, and it's reading like the temperature is saying, the temperature sensor is saying, oh, whatever I'm at for milliamps, and that has to be translated into a certain temperature. We went over that. But the point being, the person doing point to point is trying to figure out whether the points that are different points that are on the air handler are reading correctly, both the inputs and the outputs. So going back to this right here, so they make the point that correct mapping on the graphical user interface. The user interface is like the computer that someone's reading to see on a building automation type system. But it could be just the user interface on the air handler too. So it could be anywhere on the user, wherever the user interface is. Is it showing up correctly on the user interface? And then they make a list. They say check the sensors, verifying device's accuracy. That's kind of what I was just saying. Like, is the temperature sensor reading accurate? Is it mapped correctly? It may be a coincidence that another sensor on the system is reading the same value. And that's what I kind of was trying to show, is like, okay, you have a couple temperature sensors here. Do we have the right one? Do we have the right sensor? Are they reading correctly? Are they showing up correctly on the HMI, the human machine interface? Oh, here they're calling it the graphical user interface, whatever. The outputs, so you could have like on, off. So what on this list to be on or off? The cooling, enabled, disabled is an output, right? So anything fan, start, stop, that's an output. And so you're testing that this output on the controller is actually able to do exactly what it says. Is it able to start and stop the return air fan? Is this button that says that it's the return VFD speed control, is it working? Does it have, and it's output? Notice that all of those are the A's, so those would all be gradient outputs, not necessarily on or off, because the speed control could be a grade. The damper is going to open and close to a certain amount. It's not just either open or close. They're all the, I believe, analog, I think is the term. They're reading milliamp stuff. Analog input. So we got just making sure the point-to-point idea is just to make sure that all these points are actually working correctly. Okay. Let's see if this white paper has a whole bunch. Okay. The point to point is part of the commissioning process, and it would be part of the, probably in my mind, the pre-functional test plan, because it's the functional test plan. FTP is usually the last thing. Functional test plan versus pre-functional test plan versus, anyway, there's a whole bunch of layers to commissioning, and like I said, like the last one is to make sure the entire thing's working, the entire system seems to be working and functioning. This entire thing is working. But one of the steps is the point to point that we are talking about. One of the steps to get to that point, to make sure that it is all working, is to check out all these points. We get to tab. Now, we have the sequence of operation. I mentioned that earlier. So once we get to a point where we want to make sure the entire system is working, then there is a test sequence written by the commissioning agent that's going to test to make sure that the sequence of operation is actually working. So do the economizers turn on under these this parameters? Is the supply plan running under the correct parameters? So they take the sequence of operation and say, okay, well, how is the sequence of operation working? Or what is it saying that the equipment's supposed to do? And then they write a test to try and make sure that that can be done like that. So that, let's just read a little bit of this. Let's see. Okay, perfect. Smoke detection. Upon receiving a smoke signal, the supply and relief fans shall stop. Well, how do they stop? They stop because they have the supply. Here's a return fan right here. That's an output. This thing's telling it to stop. But when does it do it? So we know that the point-to-point works. We know that the point will make it stop or start. But we've got control logic that says, somebody wrote some control logic that says when you receive an input from the smoke detector, then the supply and relief fan shall stop. The outdoor air relief dampers shall close. The return air damper shall modulate to open. Detectors shall be hardwired to the supply fan starter. Okay, cool. So somebody writes a little script, a test sequence that says, first we're going to get everything running, have the air handler all running, and then we're going to trip the smoke signal. And what we should see, if we programmed it correctly, is all this stuff should happen. The supply fans should all stop. And then you're literally seeing if the supply fan shut down. Yes, it did. Did the outdoor air and relief air dampers, which are these dampers right there, did they shut? And then the return air damper opens. Return air damper right there opens up. So somebody just writes a little script to see what they would expect to see. And that's one of the last, they're running through the sequence of operation to make sure that it's doing that. And that's sort of like the functional performance testing in a nutshell. Running through all these little things. Testing the setback mode, meaning when you go to nighttime, right? They're gonna have a little sequence that says, okay, trip the timer, make it say that it's now whatever time that it's the nighttime mode, and let's watch the system on its own go to that mode. And if it doesn't, then you're going back to the pre-functional testing and figuring out why it didn't do that, or reprogramming or whatever. Hopefully that made sense as far as what the functional performance testing is trying to do. So the generator, like I said, like what is it? We talked about the generator a little bit, but starting up the generator is not the same as running it through its sequence of operation. Did when we tripped the generator and cut power and generator turned on, did it continue to enable all this stuff right here? That's kind of like the test, right? And that's an entire system to make it work rather than just a couple components, right? Lots of different components on this that work together as a complete system, right? The FCUs, the exhaust fans. Anyway, hopefully that made sense. Here's another view of like the point-to-point list, and I think I have nope. That's okay. So one of the things that would be testing would be making sure that you're going like the entire system is functioning and reading, right? The BACnet system. So we're talking all the controls and stuff. And so it can be super complicated or it can be super easy. And in this case, with lots of different controllers, I don't know that it's super complicated, but the point being you're going all the way back to Weber State's building automation control system to make sure that it's working there, that you're seeing it there. So on this case, what we're looking at, and not the same set of drawings right here, but if you're on like a campus one, you'd be going all the way back with the commissioning process to make sure that the user interface on the wherever the building automation is for the campus is seeing it too. All right, so I did point to point, talked about I feel like I got it. Might be. So my daughter just walked in. I'm back talking again. Whoops. Hopefully I got that edited out okay. Now most of what we spent time on was commissioning something like HVAC, and I've had a really some of the highlights of what I feel like I enjoyed a lot of was testing not just HVAC but different process equipment, and so with the amount of federal government work that done in part of my career and dealing with all the equipment in there. I remember one of the projects had avionics air, it had hydraulic systems, it had just kind of running through it, paint booth with huge air handlers, aircraft hangar doors that we'd commission. Like I said, it had a regular HVAC system. It had big industrial waste lift station that we commissioned. Had, like I said, paint booths. It had snow melt systems. Had a blast booth. Had robotics, fire suppression system, foam. Part of that fire suppression system was the foam generators. And when it came time to make sure that building was working correctly, not to mention all the electrical systems and security and security, what is that called? Mass notification systems, the telecommunication systems. I mean, you start getting into all that we ended up doing to make sure that building would work. It was a lot of fun. I really enjoyed it, and it's things to schedule. It's a lot of communication. It's a lot of coordination. And you think of like the amount of coordination it takes to build something that I tried to get to at the beginning of these lectures was how much needed to coordinate. There's a lot of coordination that needs to happen when it comes time to run through the paces of startup sequences, and then getting into point-to-point, getting to flush fill test fit, flush filling, making sure that different systems are reacting the way they're supposed to be, reading the way they're supposed to be reading, and then functional performance testing it. It'd be a lot of fun and just a lot of coordination. One thing I would share, maybe this like the closing comment, and it seems to be that the folks that do the programming, I like them a lot. This is maybe too generic, but it seems like sometimes the folks that do the actual programming uh, are more introverted and be happy to not share a lot of information. So I don't blame them. Uh, but if you can learn a little bit about the systems and subsystems and ask them intelligent questions, they'd be happy. It seems like that those folks, even though they don't volunteer a lot of information, when you start asking them at least about the systems and using some intelligent language about how the system's functioning and how the programming is going and what points are we working on and all that stuff, they'll start talking and opening up and be really fun to chat with and to coordinate with. So really enjoyable time on all those systems. Is some of my favorite work in my career is being involved in heavy industrial type process stuff. So we'll end the lecture there, and we'll see you in the next one.